this is what the finished player looks like. Just a capsule collider with two triggers next to it. And this is what the player can do. You can move, sprint, crouch, jump. So as I was saying, you can move around, sprint, crouch, and jump. You can lean to the left and you can lean to the right. You can pick up items of importance, pick up items, and throw them. Same goes for this box. You can push certain items, which are meant to be the more heavier sort of furniture that you can find around the level. You have the inventory, a lantern. The way the player works is it has the main camera, which controls the player using the player controller script. If we have a look at it, this is my player controller script. It's nothing too complex. All of this stuff here is Boolean checks, input, float, and other stuff that I had like set up, like such as the speed, how much the player can jump, the sprint speed, the normal speed, and the crouch speed, all that sort of stuff, and any other game objects the player needs to interact with to be able to work. In start, I've set player is grounded true just to allow the player to jump by default, and I've set the speed to the normal speed before the player actually starts running, and I've set this so the player can jump. What I'm doing in update is I'm getting the input, forward input and the sideways input, basically the vertical and horizontal axes. I then put those in one vector free called movement, and movement is passed through the player movement void, which is right below here. This is a previous attempt at making my player move. I used move position so that I could get a responsive player controller. However, what I found out later on is that using this way of moving the character would allow me to glitch through walls if I was going fast enough, which is something I didn't want. So the way I fixed it was by using player RB dot velocity and setting it to the X direction times by the speed times delta time, keeping the velocity as it was, and the Z direction, also times by speed and times by time delta time. The reason why I had to put velocity.y in here is if I didn't do this, the player would end up slowly floating down after jumping, and that's because the velocity would override everything when it came to the movement. Either way, the movement is done in fixed update because it's physics based. Here we have the jump function. Pretty simple. It checks if the player presses a spacebar, it checks if the player is grounded, and it checks if the player is allowed to jump. If all of this criteria is met, it will add force to the player rigid body in the up direction by the jump amount. Obviously, while the player is in midair, it means the player is not grounded. So that is set up right here. The sprint function. I've used a different approach here for this project just to see what would work best. What I did is I check if the player presses down the left shift key and if the player releases said key. Now, if you press it down, all it does is just set a boolean to true or false depending on which state it is in. The same thing goes for the crouch function, where if you press left control, it changes the height of the player so that way you can crawl in smaller spaces. It doesn't allow you to jump, and it sets is crouching to true. And when you let go, everything goes back to normal. Now, the is running and is crouching booleans come into play in this void, the check player state, where it checks if the player is crouching, if the player is running, if the player is walking, and it stops the player from running while crouched. The way this is done is if the player is crouching, true. The way this is done is checks the player is crouching and is not running, then it sets the speed to the crouch speed. If the player is running instead, it sets the speed to the sprint speed. Checks if the player is walking by not running and not crouching, speed is normal speed. This here checks if the player is crouching and doesn't allow it to run just by changing this boolean right here. All of these void functions are called in the update, except for the movement obviously. Next up is the player lean function. It checks for the input and it checks if the player is allowed to lean in the right direction. What it then does is it disables the main camera and it enables a second camera. I did this because if I moved the main camera, also the camera with the script, it would mess things up and it wouldn't look good or work well either. So I overcame this issue by having a second camera. And when I switch between them, I just disable one and enable the other. What I then did is, after this lean camera, the second one that is only enabled when you try to lean, it moves to an empty game object in the scene that's part of the player, which is to the side. This is done simply by setting the transformed opposition to the mentioned game object position. It also rotates the camera slightly to make it seem like the player is actually leaning rather than moving their head to the side. It also enables a collider to stop the camera from glitching through walls or inside objects. And then if the player lets go of the E key, all of this is just undone by setting the transform position back to normal, enabling the main camera, disabling the second one, resetting the rotation, and disabling the collider that was enabled not long ago. Same goes for the for lean left. Only difference is it has a different game object, different input, and a different boolean, really. That is about it for the player controller. Now, this boolean, the can lean right and the can lean left, I wasn't too sure on how to make them work. What they do is they check if the player is up against the wall. And if the player is up against the wall, the player just can't lean in that direction. Therefore, it stops the player from glitching through walls or like seeing through walls. If I try to lean left, however, I can do so with no problem. As you can see, I can also lean right. When I come here, I no longer can. These are the empty game objects that check if there is a wall in there. I wasn't too sure how to approach this, so I made two separate scripts. Lean left check and lean right check. They basically do the same thing. Only thing is, one goes on one of these game objects and the other goes on the other. By default, it allows the player to lean to whichever direction the player wants to lean. And checks if another object, in this case a ground object, enters the collider. If that's the case, it doesn't allow the player to lean. And this is used by bringing in this player controller script and using the boolean that is used in here, the can lean right and the can lean left. Another thing is the ground check. This is what allows the player to jump. I wasn't too sure to approach this either, so play it safe. I just made a separate game object that has a collider the size of the main player collider, and if this, which is a trigger collider, touches the ground, it then allows the player to jump. But the way I approached making the player crouch was by changing the height from 2 to 1 or vice versa. And I made another script for the ground check, and while it does check if the player is grounded, it also makes sure that the ground collider game object has the same height and radius as the player capsule, which is done in update. Next up is the camera controller. It takes all the variables it needs, such as the float, X rotation, the mouse sensitivity, which is set in the inspector, and the player transform. On start, it locks the cursor. This way, when the player starts the game and they play throughout the level, they don't have to worry about clicking other things on their monitor or going outside the window, as their cursor is just locked in the game view. In the update void, it takes the mouse input, specifically the mouse X and the mouse Y. These two values get times by time.delta time and the mouse sensitivity. This bit of code rotates the camera up and down, while this one allows it to rotate left and right. It also resets the mouse rotation if the mouse X equals to 0. What I have here is the lock cursor and the unlock cursor. I didn't end up using the unlock cursor, it's just kind of left over. Up next, the inventory system. This didn't take me too long. It just simply checks for a bunch of booleans, and according to those booleans, it enables the corresponding game objects. Let me show you. So by default, your inventory starts off as empty, as you haven't gone through the game and picked up what you need just yet. And when you hold down tab, the inventory gets enabled. I decided to make this a 3D game object just to try something new. But however, I figured out that when you would look down or when you would be up against the wall, the inventory would go behind the wall and you wouldn't be able to see it. The way I worked around this is fairly simple, and it's a trick that a lot of games, especially first-person shooters do nowadays. And that is using multiple cameras, specifically a camera that renders the entire world, which is the main camera, and another camera that only renders out, in my case, the inventory. And that gets overlaid on top. So when I go up against the wall, I always see my inventory. When in reality, if I pause the game, you see that the inventory, which is just a hollow box I made in Blender in like a minute, less than a minute, but you see it's behind the wall. In order to do this, I had to use URP, the Universal Render Pipeline. Anyways, I used the same thing for the lantern. That way, when you go up against the wall, rather than have the hand clip through the wall, it looks as if it's just against it. Anyways, the inventory system. As you can see, at the moment it's empty. And I made this for the important items that you need to carry throughout the levels in order to finish the game. And these are just fragments of a sword I made in Blender. You can pick them up one by one in any order, and they all show up here. This is simply done, as I've mentioned before, by taking a bunch of booleans. And then if said boolean is true, it enables the correct game object, which is the item you see in your inventory. The way I approach this is when you pick up an item, it disables it and it takes the correct boolean, enabling a different game object in the inventory. So if I show you right here, this is the inventory. Oh, just a second. There we go. This is the inventory with the different items in here, and they all get enabled because of that script. When all the fragments are collected, the player is then allowed to enter this sort of dimension where there is a temple to actually put the fragments together and make a sword. In the test scene, however, that temple is just this little pedestal. You come in here, you click, and the sword appears. I haven't changed it in the sample scene, in the test scene, which is this one right here, but in the main game level, once you enable this completed sword, all of these items disappear. And when you pick this up, it replaces all of those items in your inventory, and it's just this one. And this is what you need in order to actually finish the game. And allow me to show you really quick. This is the main level, which is multiple levels. Some of them are not rendered in just by enabling and disabling them. But if I hop on over to the end, to the temple that brings the components, the sword fragments, to the temple that brings the sword fragments together, I will just demonstrate really quick how this works. But to do so, I will move the player over in this scene, and I will take out the dagger prefabs that I need. Handle, tip, mid. And if I now hit play, as you can see, my inventory is empty, and I can go ahead and pick these up. Ooh. As you can see, where has the... Here it is. All of the fragments are in here, and if I walk into the temple or on top, as you would when you approach this through that portal, if I click, the complete dagger appears, and when I hold tab, the inventory is empty. And then, of course, when I pick it up, it shows up there just fine. The inventory system works together with the temple events. Temple events is just a script that goes on an empty game object, and which has a trigger collider, and it checks, can the player unite the fragments? Yes, it enables the sword, the full finished sword, only if the player doesn't have it. The temple event script is a script that goes on empty game objects and it works together with the inventory system. What this does is it checks when the player enters the trigger collider on said game object, and it checks for the input, in this case clicking. It checks if the player can unite the fragments, which is set by the player having all of the fragments in their inventory, and it checks that the player doesn't already have the full finished sword. And all this does is just change the boolean as sword to true, and it enables the full sword game object that is hovering above the temple. Next up is the interact system. Now, this one gave me a bit of a headache when I was writing it, as I was trying to figure out which way is best to do things. I ended up giving up on it and came back to it like a couple of days later and made a new script, which is basically what I have now. The old script, however, is this. Doesn't have much because I ended up just copy pasting, cutting things out, and kind of just left my original attempt as notes below the entire script, just in case I needed to like look at it or get something from it. Now, that's my old interact system. The new one is not perfect. It's got all the things it needs, so like the layers, the float settings, the UI crosshairs, and the player grab points. The player grab points, they're easy. They're just two empty game objects, specifically this orange one and this red one. And depending on which item and its importance, so if it's like a key, it goes to the orange point. If it's just a regular object like a chair, it goes to the red game object. So that's all they are. If we take this game object here and we look at the layers, we have layer A, B, C, D, and E. Now what these do is layer A is for important items such as keys or fuses. Shoots a raycast, and if you're not holding an item in the layer A slot, it enables the UI crosshair to indicate that you can pick up the item that's in front of you. And then if you click, it disables the UI image, which is just a simple dot. It takes the game object's collider, stores in hit object A. It also stores the collider and the rigid body, and then sets the holding item A to true. This way you can't just like pick up more items. Otherwise, it sets the crosshair image as false. It disables it. Same goes for B, but slightly different. It just doesn't take a collider as well. Ray C, layer C, it's the same thing really, and the same goes for D. Almost. We also have a layer E. Now, this is all done in the update function, which is also not very efficient, and I'm aware of this. But basically, it checks if you let go of the grab key, and it lets go of the item A if the player is holding an item with the layer A set to it. And the same goes for B. This is what actually allows the player to grab items in layer A, and this is for layer B. Layer C is the one for heavier furniture that you can find around the house that you can't pick up, but you can only push. This is the script that takes care of that. I've also just used the same thing, but used it for in a different void called push door. This is so you can either open the doors by walking into them, or you can click on the doorknob, which is just a cube with the corresponsive layer. The push door void is exactly the same as the push item void. However, it works for items in the E layer. And what these items are is just doorknobs. It allows the player to push the doors open slightly. The throw item void works for items in the layer B, in the B layer. And it simply checks if you right click, it sets the holding item B to false, and it just adds force to the object. Layer D items are the sword fragments and the full finished sword, and this is what adds the items to your inventory. That is it for the interact system.